Question number 36. If Aufbau's principle is not followed, rather energy of orbital varies only with n, then what would be the magnetic behavior of the zinc 2 plus ions in aqueous solution? Students, if we talk about this given condition, it is mentioned to us that Aufbau's principle is not followed and the energy of the orbital varies with n only. So what the examiner has mentioned to us in the question is that, students, every orbital in a given shell is degenerate. So the energy of 2s and 2p will be equal. The energy of 3s, 3p and 3d will be equal. The energy of 4s, 4p, 4d and 4f is also going to be equal, students. So all of these orbitals belonging to a particular orbit are going to be degenerate. So if we talk about the zinc 2 plus ion, students, the zinc has an atomic number equal to 30. So zinc 2 plus is going to have 28 electrons. So we'll just try up filling them. So 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. Students, we can clearly see that all the 28 electrons are accommodated in this given electronic configuration. So students, all the electrons are paired up in this case. So it does not matter if the n plus L rule is followed or not. Zinc 2 plus ions is going to be diamagnetic under the given set of conditions. So students, for question number 36, we have to mark the correct answer as option 2. Let us look at the next question now. Question number 37. The principal quantum number of an orbital S1, it belongs to an orbit in H atom with degeneracy equal to x, is n. So students, if we use this information which is given to us, so the orbit number is equal to n and its degeneracy is equal to x. So students, we can clearly see that the value of x shall be equal to n square. Okay, this is the first condition which is given to us. Further, it is given to us that the azimuthal quantum number is L. The number of radial nodes is greater than the number of angular nodes for state S1. Okay. So if we talk about the second condition now, it is given to us that the number of radial nodes is greater than the number of angular nodes. Okay. So if we talk about the number of radial nodes, students, it is n minus L minus 1, the principal quantum number and the azimuthal quantum number. Okay. And if we talk about the number of angular nodes is given by L value. Okay. So this is the second information which is given to us, students. So if we try and simplify this expression, students, we are going to have n is more than 2l plus 1. Okay. Okay, so these two conditions have been given to us by the examiner. Okay. The examiner seems to be interested in which of the following statements does not hold. Okay, so we have to select the incorrect statement. If you look at the first option, students, in the first option, it has been given that x is equal to 2l plus 1. Okay. So students, we have a relation between n and l and we have a relationship between x and n. So using these two information, students, we can clearly see that the first option is not correct. Okay. X was equal to n square, and since n is more than 2l plus 1, so x will obviously be more than 2l plus 1. If we talk about the second statement now, x is equal to n square, so this was the first condition which we had derived. So this is correct, students. If we talk about statement 3 now, n is more than 2l plus 1, this is also correct, students. This was derived using the condition of the nodes which are given to us. And if you look at the last statement now, S1 cannot be 3D. So students, if we talk about 3D, we have n equal to 3 and the value of L is equal to 2. So if we try and put this n and L value in the above condition, students, we can clearly see that this is not satisfied over here. So students, this is also a correct statement. It says that the state S1 cannot be 3D as it does not satisfy the given conditions. So statement 4 is also correct. So students, for this question, we have to select that statement which is not true and we have to mark the first option as the correct answer. Let us look at the next question now. Question number 38. Consider the given conversions. So we have been given 4 different conversion, students, and the examiner seems to be interested in the statement which is not true about these given enthalpies. So students, we have O converting into O plus as delta H1. So this is the IE1 of oxygen. If we talk about the second one, students, in the second one we have O converting into O negative gaseous. So this is delta HEG1 of O. If we talk about the third reaction now, students, in the third reaction we have sulfur gaseous converting into sulfur plus gaseous. So this represents the IE1 of sulfur. And if we talk about the last option, we have sulfur gaseous converting into S minus gaseous. So this represents the delta HEG1 of sulfur. So if you look at the statements which are given to us, students, in the first option the examiner says that the magnitude of delta H1 is greater than that of delta H2. So this is a correct statement, students. More energy is required to ionize any atom as compared to the energy which is released when an electron is added to the atom. So statement 1 is correct, students. If you talk about the second statement now, magnitude of delta H2 is greater than that of delta H4. So if you talk about delta H2 and delta H4, students, we can clearly see that this is not correct. Delta HEG1 of sulfur is more negative than that of oxygen. So if we talk about the magnitude, the delta H4 value is going to be greater than the delta H2 value. So second statement is not correct, students. If we talk about the third statement now, magnitude of delta H3 is greater than that of delta H4. So this is also correct, students. We can clearly see that in the third reaction there is ionization happening, and in the fourth reaction an electron is getting added. And as we had discussed before, it is more difficult to ionize any atom than to add an electron to it. Okay. So this is also a correct statement, students. If you talk about the last option now, it says that the magnitude of delta H1 is greater than that of delta H3. So this is also a correct statement, students. We know that the ionization energy of oxygen is more than that of sulfur. Okay. So out of these given statements, students, only the second statement is not correct. And for question number 38, we have to mark the correct answer as option 2. Let us look at the next question now. Question number 39. Consider the Maxwell-Boltzmann plot for distribution of molecular speeds for two different gases A and B at temperatures TA and TB with molar mass MA and MB respectively. So we have been given the Maxwell-Boltzmann plot, students. The graph for gas A is given as this one and the graph for gas B is the other one. Okay. The examiner seems to be interested in the molar masses of A and B and the temperatures of A and B. Okay. So if we talk about this given graph, students, we can clearly see that the most probable velocity or the most probable speed of gas B is greater. So if we talk about the most probable speed, students, it will occur around the maxima. So this is for gas B, and if we talk about gas A, this is the most probable velocity for gas A. Okay. So this is for A and this is for B, and we can clearly see that the most probable speed for gas B is more than that of the gas A. So students, we can just put the formula of this molecular speed or the most probable speed, students. We have under root of 2RTB by MB is more than under root of 2RTA by MA. So upon simplification, students, we have TB by MB is more than TA by MA. So we can further rearrange this. We are going to have TB into MA more than TA into MB. So the first statement, it says if TA is greater than TB, MB can be greater than MA. This is not correct, students. The product of TB and MA is greater. So students, if TB is lesser, MA has to be larger. If you talk about the second statement now, if TA is lesser than TB, then MB can be lesser than MA. Okay, so this is the correct statement, students. If TA is lesser than TB, it can be a possibility that MB is lesser than MA. So the second statement is correct, students. So S1 is not correct and S2 is correct. And if you look at the statements which are given to students, we can clearly see that for this question we have to mark the correct answer as option 2. Let's look at the next question now. A gaseous mixture of 80% helium and 20% nitrogen are taken in a vessel X. A small hole is made in the vessel and the gaseous mixture is allowed to effuse out into another evacuated vessel Y. The composition of the initial mixture, that is number of moles of He to number of moles of N2, effusing out from the vessel X is equal to. Okay. So if you talk about the rate of effusion of helium to the rate of effusion of N2, students, we know that it is equal to pressure of helium upon pressure of nitrogen into under root of molar mass of nitrogen upon molar mass of helium. Okay. So since the gaseous mixture is 4:1 in He:2N2, students, so we can clearly see that the pressures are also going to follow this ratio, students. So it is 80 and this is 20. So this will come out to be equal to 4. And if you put the value of molar mass, students, molar mass of nitrogen is 28, whereas the molar mass of helium is 4. Okay. So this on simplification comes out to be equal to 4√7. So if we look at the options which are given to us, students, we can clearly see that for this question we have to mark the correct answer as option 2. Let's look at the next question now.